Okay, so in the warm-ups, we were talking about how to solve a linear system in two variables. And that's what you worked on in Algebra 1, and you guys all seem to do very well on the warm-ups. But today we're going to be talking about a system of three linear equations. So that means that we're actually going to have three variables, x, y, z, or a, b, c, or any other three variables. And if we have three variables, then we need to have three equations in order to be able to solve them. The solution of this system is going to have three solutions. When we're solving for x and y, we're working within the plane. So like we have the x-axis and the y-axis. What do you think we add on if we have x, y, and z? We're not talking about just a plane. We would be talking about what? It's actually space. Okay, it's three-dimensional. So when we're talking about solving a system in three linear equations, we're really talking about where would three lines in space meet. Like I might have a line like this, a line like this, and then another line coming in like this. And at that intersection point, that's the solution. So we're talking about x being here, y being here, and then the z-axis actually comes up in a three-dimensional way. Okay? So coming down here then, how do we do this? Well, it's very similar to what we do with two variable systems. We want to rewrite the linear system in three variables as a system in two variables. So we want to use either substitution or elimination to get rid of one of our three variables. Then we can just solve that new linear system for those two remaining variables. And then we just keep using substitution until we can solve it. It's actually very easy. It's just like what we did before, as long as you're careful. We talked about this with our two variable systems. If you obtain a false equation, such as 0 equals 1, in any of the steps, the system has no solution. So you might want to just jot that down. False equation, no solution. When you obtain an identity such as 0 equals 0 or 5 equals 5 or any other true statement, then that's going to mean that we have infinitely many solutions. And we should just write that. Infinite solutions. Does that mean that any three numbers I can think of will be a solution? 1, 2, 3. Will that always be a solution? No. Because what if one of my equations is, say, x plus y plus z equals 7? And then I have two other equations. Would 1, 2, 3, would that work for this? Would 1 plus 2 plus 2? No. But maybe I could say, 2, 2, and 3. That would be a solution, wouldn't it? Even with my other ones. Okay. All right, so let's go over here. We're only going to do a few problems. We're going to do numbers 1, 2, and 7, 6, and 7. So here's number 1. So I'm trying to solve for x, y, and z. So I want to eliminate a variable. I can either eliminate x, I can eliminate y, or z, whatever's easiest. And you just kind of have to make a choice and stick with that choice. So which variable do you want to eliminate? Ryan, choose one.
X.
All right. So if I want to eliminate x, I'm going to multiply my first equation by -2. And that would give me -2x minus 4y plus 6z equals -22. My second equation, I just want to keep the same. When I add these equations, I'm multiplying everything by -2. I just double check that before I go any further. I'll make sure I wrote it down correctly. Okay, so now I'm going to combine these two. So when I combine them, I'm going to get -3y plus 4z equals -13. So now I have a system of two variables. Well, not a system yet, but an equation of two variables. So now I have to take two different equations. So I just used numbers 1 and 2. I can't use 1 and 2 again. I have to either use 2 and 3 or 1 and 3. But I have to eliminate the same variable. So if I'm going to use 2 and 3, what would I have to multiply by? -2 on my number 2 equation now. I have to use different equations. So now I'm using 2 and 3. I could have used 1 and 3 though. So I have -4x minus 2y plus 4z equals -18. I use my third one. I'm going to add these two together. My x's eliminate. I have y plus 5z equals -2. So now I have just a regular system of two variables. I've got this equation and this equation. So what do you think we want to do now? We want to eliminate a variable from one of those. So what's a real easy one to eliminate? Is y easier or z? Y. So what am I going to multiply my second equation by down here? Because now I'm looking at this and this. So I'm going to multiply this one by 3. Okay, I need a little more space. We're not doing number 4, so I'm going to come down here in this space. So I have -3y plus 4z equals -13. On this one, I have 3y plus 15z equals -6. When I add these, 19z equals -19. And so now I know what z is. Z is -1. In order to solve this, though, I have to know what every variable is. I know z is -1. Now I have to figure out what y is. I can substitute in anywhere. But if I substitute in here, I wouldn't be able to solve for y. I can substitute in here or here. Here is easier. So I'm going to have y, and then 5 times -1 is -5 equals -2. And so y is going to equal 3. So now I've got y. And now I just have to find a spot where I can solve for x. I can use any equation, this one, this one, this one, anywhere. I'm going to go back up to this one. This seems the easiest. So I'm going to have x plus 2 times y, so 2 times 3 is 6. -3 times -1 is plus 3 equals 11. So I have x plus 9 equals 11, and so x equals 2. And now I have the answer. The way that it would be written is 2, 3, -1, because I had to solve for x, y, and z. Any questions on that? All right. So number 2 is going to be very similar. We're not going to go through the whole thing, but I just want you to be thinking about how you would go about eliminating a variable. So I want to give you a couple minutes to think about it. I want somebody to tell me what you're thinking. All right, go ahead, Tim.
I think there would be no solution.
You think it's no solution? Why?
Because if you make the first two similar, try to eliminate that variable, then it would be -2x plus 2y minus 6z equals 19, and then you do the same thing, but it's equals 9.
All right, well, let's see what happens. Let's actually go ahead and see if you're right. So I'm going to multiply this whole equation by 2. I get 2x minus 2y plus 6z equals 38. Then we get this. All right, so when I add these two together, this eliminates, this eliminates, this eliminates. So over here I have 0 equals 47. So what does that mean, everyone? No solution. He was correct. So we like when that happens. Nice job. All right. Let's go over to number 6 now. All right, so thinking about how we can get variables to eliminate. What might be actually a little bit easier on this one instead of eliminating x's? Eliminating what? Y might be better, isn't it? So I'm just going to go ahead. I'm going to change all the signs in my second equation. Then I don't even really have to write it out as much. Watch how I can save some time now. So I have 1x minus 2x. That's going to be a negative 1x. I have 2y minus 2y. That's 0. Negative 5 plus 3 is negative 2z. And negative 12 plus 2 is negative 10. All right, so I'm already finished combining 1 and 2. Yes?
It says solving the substitution.
Oh, it does, doesn't it? But we are never going to do it that way unless it's the easiest way. And I don't think that's going to be the easiest way. If I wanted to do substitution, I would have to solve this for z. And then I would have to substitute that in here and here, and then I would still have to use elimination anyway. So I'm never going to force you to do it a way that's not the easiest way. All right, but thanks for pointing that out. Okay, so we've just combined 1 and 2. So now we're going to want to do maybe what? What do you think, guys? We have to eliminate y's because that's what we're starting with. What could I do? 2 and 3, or 1 and 3, whichever one you want. I think I'm going to do 1 and 3. Doesn't matter. But because I already messed with number 2, I'm just going to go ahead and write number 1. I'm going to have to multiply 1 by 2. So it's going to be 2x plus 4y minus 10z equals negative 24. Okay, so now I'm going to do 1, my new 1, and my 3. So I'm going to have 5x. Y's are going to cancel. Minus 11z equals negative 13. All right, so now what is my only option here that's going to be a pretty quick thing to do? Multiply the first equation now by what? I need to eliminate these x's. What am I going to multiply this by? 5. So I'm going to multiply this one by 5. Negative 5x minus 10z equals negative 50. So now I'm going to have negative 21z equals negative 63. While you're doing this, you should always be thinking ahead. If we're going to get something that is a fraction, a really ugly fraction, we probably did something wrong. But this is going to be fine, isn't it? What's z going to be here? 3. But if it was going to be like 63 over 20, we probably made a mistake. All right, so z is 3. So now I just have to work backwards and substitute in. I can choose anywhere. Let's see. This would probably be the easiest. So I'm going to have negative 1x. Negative 2 times 3 is minus 6 equals negative 10. So negative 1x is going to equal negative 4. So therefore x will be 4. So now I know x is 4. I know z is 3. And now I have to figure out what y is. I can go back anywhere. I'm going to go back to this number 1. Looks like the best spot. So I will have 4 plus 2y. Negative 5 times 3 is negative 15 equals negative 12. And so I'm going to have 2y minus 11 equals negative 12. So 2y equals negative 1. And so y then is going to be negative 1/2. And that's okay. It's not a super ugly equation. Tim?
So, could you use one of those first three equations to find one, in this case, it'd be x, we just use the easier one?
Yes. Yeah, you are right. If you feel substitution would be easier in this case, if I solve this for x, I get negative 12 minus 2y plus 5z, and I would plug that in for this for x and for this for x. and then I would use those two equations. Now, it wouldn't have been so bad on this one. It wouldn't have been awful, but I think elimination's usually easier. But if you had a lot of small numbers and an easy thing to solve for, you might want to go ahead and do that. All right, one more here, guys. And it says you found $6.60 on the ground at school, all in nickels, dimes, and quarters. You have twice as many quarters as dimes, and 42 coins in all. How many of each type of coin do you have? How do we start this, Anish?
Well, we start off by making the dimes X.
Okay, now I like to go in the order in which the values occur. So what comes first? Nickels. So I would go with X equals nickels. I just think it's easier when you go back and read the problem. But I do agree, we're just going to do like you said. All right. So now we need some equations. Can somebody think of an equation we can write? What do you think? And if they're good. So x plus y plus z equals what? Okay, I don't agree with that though. X plus y plus z is actually going to equal something else. What's it going to be, Olivia? 42, right? You caught your mistake. Because with that $6.60, we have to be thinking of how much each one of these is worth, right? So, Alexis, what am I going to do on that then? So how much is our nickel worth? Okay, so I'm going to make that 0.05x plus 0.10y plus 0.25z. Now, what's that one going to be equal to? What's that one going to be, Jacob? Right, $6.60. Okay, so we have 3 variables. We only have 2 equations. So we must have one more equation to be able to solve. Jacob? 2z equals y. Let's double check that. Okay, so it says you have twice as many quarters as dimes. Okay, so let's see if we agree with that. So if I have 5 dimes, how many quarters would I have then if I have twice as many quarters as dimes? 10, right? So let's see if that works for his equation. This is the way I always check it. If I do 2 times my number of quarters, will it be equal to the number of dimes? See, look, it says we have twice as many quarters as dimes. So if I have 5 dimes, I have to have 10 quarters. That's the rule. Would that work for this? If I do 2 times 10, is that going to equal 5? So which way should it be? Instead of 2z equals y, it should be what, Jacob? Right, z equals 2y. And that's a confusing thing there. So I always just make up numbers and then keep checking it until it actually works out. So this is the way it should be then. So how could I rewrite this? I could say 2y minus z would have to equal what? Or I could even just leave it like this. Let's leave it like this. This is actually better. Because what can I now do? If z has to equal 2y, I can now do what? Substitute. I can substitute in here and here. So I'm going to now have, I actually do have 3 equations. I'm going to have x plus y plus 2y must equal 42. What am I allowed to do to this to get rid of these decimals? Multiply everything by 100. So I'm going to go ahead and do that. But while I'm at it, all of these can actually also be divided by what? 5. So I'm going to make my equation easier to work with. What is that? 6 divided by 5 is 1 with 1 left over. 16 divided by 5 is 3 with 1 left over. That's 132. Okay, so this is my equation then for this, and I'm going to have to replace the z with 2y. So now this equation is going to be x plus 2y plus 5 times 2y. All right, so we've got x plus 3y equals 42, x plus 12y equals 132. Okay, so now I want you guys to solve that. If I had only asked for the setup, which on your homework, when you check Canvas on your homework, one of the problems, number 30, it says just set it up. So you'd be able to stop right here with just your setup, but I want you to go ahead and solve. Anish?
Can you add another equation that says, oh, never mind.
You could have done 2y minus z equals 0, and we could have used elimination. But in this case, since we have z equals 2y, it's easier to just use the substitution and eliminate that variable that way with the substitution.
Well, I was going to say do 2x equals y, but then I realized that it's not the value, it's the amount.
Right. Okay, so go ahead and solve. And then check up here when you're finished.